Hi everyone, good day and welcome to my class today. I am still Maths with Victor. Kindly like, follow and share my Facebook page to all your friends and also subscribe to my YouTube channel. Today I want to explain the laws of indices, the laws that guide us while dealing with problems involving powers, because indices in its basic form means powers. So we look at the laws and then explain them, and in subsequent videos, we are going to solve problems. All right? So we start with the first law of indices. The first law of indices. But before I look into the first law, anytime you have a number expressed in powers, then we are talking about indices. For instance, if I have 2 raised to power 3, this expression is written in what we call the index form or the power form. And in index form, there are 2 things there. The first one here and the next one there. This one is called the base, and 3 above the base is known as the powers. So we now quickly proceed to the laws of indices, and we start with the first law of indices, law number 1. In law number 1, if we have a raised to power m times a raised to power n, I want you to notice something very well. The 2 bases are the same, very important. So you have a base to the power of m. You have the same base to the power of n. The first law of indices states that we pick out just one of the base, which is a, and then we add the powers, m plus n. Very important. So when we have a number to a power multiplied by the same number, the base must have to be the same thing to another power. Just pick out the common base and add the powers together. As simple as that. A simple usage or illustration of this law is when we have, for instance, 2 raised to power 5 multiplied by 2 raised to power 3. We can simply solve this problem using this first law of indices. Since the basis we have is the same number, 2, we can pick out the common base, 2, and then simply add the powers, 5 plus 3, and this will give me 2 raised to power 8. As simple as that. Of course, we can solve this problem by repeated multiplication. I will quickly show you that. The same problem, 2 raised to power 5 times 2 raised to power 3. Of course, they are in index form. By repeated multiplication, 2 raised to power 5 is the same thing as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Of course, this means you multiply 2 with itself in 5 places, which is what I've done. So I've dealt with this. Then I still have a times here, times. And then 2 raised to power 3, multiply 2 into 3 places with itself. You still have 2 times 2 times 2. So this expression in index form is the same as this expression in expanded form. And then if you look at this very clearly, you can see that we have the same number 2 all through. So we can still convert back to index form. 1, 2, 3, 4, 5, 6, 7, 8. This will give me 2 raised to power 8. The same result we got here. But instead of following this rigorous process of expanding, the law, of course, is there to guide us to simplify the work. That is why we have the laws. So instead of having to go through this step, I will just pick out the common base and add the powers, 2 raised to power 8, the same thing. So the laws of indices makes the work to be easier and simpler. This is the first law. I'm going to look at the second law very quickly. I will run through all the laws. The second one, I have a raised to power m divided by a raised to power n. Remember, the first one has to do with multiplication. In that case, you add the powers. But the second law is the law of division. When a base raised to the power of a number is divided by the same base raised to the power of another number, you pick out the common base since they are the same, and then you subtract the powers m minus n. m minus n. So you apply the law of subtraction of powers when they are dividing, and the law of addition of powers when they are multiplying, like we've seen in the first law of indices. Then a simple illustration of this law, if you have 2 raised to the power 5 divided by 2 raised to the power 3, if you look at this very well, the bases are the same. The laws must be applied when the bases are the same thing, a and a, 2 and 2. So since the bases are the same, I will pick out the common base, and in this law, I will subtract the powers. That will give me 2 raised to the power 5 minus 3, and 5 minus 3 is 2 raised to the power 2. Answer, a simple illustration of the second law of indices. Just like I did previously, we can also solve this problem by repeated multiplication. 2 raised to the power 5 divided by 2 raised to the power 3. I can expand this number as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Of course, divided by 2 raised to the power 3 is 2 times 2 times 2. Then these 2, we cancel one of the 2's up. 1, 2 here, cancel 1, 2 up. And then the last 2 cancels the last 2. At the denominator, we are left with nothing, 1. But at the numerator, we have 2 times 2. Only this is left there. And 2 times 2 in power form is twice, so it's 2 raised to the power 2. That is still what we had here. But why go through the rigors of expansion when we can apply the second law of indices? As simple as that. Remember, the laws are to guide us to make the problem easier. I will run through the third law of indices. The third law of indices, what we call the zero powers. If I have a raised to the power 0 is equal to 1, this law simply says that anything raised to the power 0 gives you 1. It doesn't matter what the quantity is, what the number is, as long as the power is 0, the result is 1. For instance, if I have 2 raised to the power 0, the answer is 1, as long as the power is 0. If I have 5 raised to the power 0, the answer is 1. If I have 1 million raised to the power 0, the answer is 1. If I have x raised to the power 0, the answer is 1. So you must have this at your fingertips, that anything, any number, any quantity raised to the power of 0 gives you 1. That is the zero power of indices. I can move on to the fourth law of indices, law number 4. That states if I have a to the power of m, then to the power of n. You notice we have 2 powers here, a raised to the power of m and also raised to the power n. This law states that since there are 2 powers, you multiply the 2 powers. So this is the same thing as a raised to the power m times n, which is the same thing as a raised to the power mn in algebra. So when you have a power raised to the power another power, you multiply the 2 powers. A simple illustration, if I have 2 to the power of 5 to the power of 3, 2 raised to the power of 5 raised to the power 3. In this law of indices, you simply multiply the 2 powers. That is 2 raised to the power 5 times 3. That will give me 2 raised to the power 15. The fourth law of indices. Of course, I can also show this using the extended form of multiplication, that 2 raised to the power 5 to the power of 3 means the same thing as 2 raised to the power 5 times 2 raised to the power 5 times 2 raised to the power 5. Because this quantity we are raising to the power of 3, so we'll multiply it 3 times by itself. 2 raised to the power 5, 2 raised to the power 5, 2 raised to the power 5. Then by expansion, 2 raised to the power 5, the first one, is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Times the next one, 2 raised to the power 5, is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. I'm done with this. Times the last one, 2 raised to the power 5, is still 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. But if you look at the expression we have 2's all through the same number. So we can convert this back to index form as 2 to the power of, you count how many twos you have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2 raised to the power 15 as the answer. But why go through the rigors of this expansion when you can apply this law by simply multiplying 5 and 3? You get the same result. All right? So this is the fourth law of indices. Quickly, I will run through 2 more laws, and then in our subsequent classes, we apply the law to solve problems. Law number 5. Law number 5, if I have x to the a, I was using a previously. If I have a raised to the power minus 1, this is called the negative powers. Anytime the power is negative, we apply the laws of negative powers. And this law of negative powers says we can convert the powers from negative to positive. But once you convert the powers from negative to positive, you take the reciprocal of the quantity. So if I convert this to 1, I'm going to take reciprocal. Reciprocal means you turn the quantity upside down. So A becomes 1 over A. Originally, A was a numerator here, but here it is a denominator. That is the law of negative powers. A simple illustration of this law, if I have 2 raised to the power minus 1, it's the same thing as 1 over 2. I will change the power from negative to positive, but I will turn 2 upside down. Another illustration, if I have 2 over 3 raised to the power minus 3, negative power of indices, I'm going to change this power to positive, but I will turn this quantity upside down, reciprocal. That becomes 3 over 2. Denominator becomes the numerator. Numerator becomes the denominator, and then raised to the power 3. The power has changed from negative to positive. So in the negative powers of indices, you can change the power from minus to plus, but the quantity must be reversed. Very important. Then finally, the law of fractional powers. I think that's number 6. If I have a raised to the power x over y, for instance, I think I was using m and n before, so let me maintain the terms I was using. So if I have a raised to the power m over n, so if you look at these powers very well, these are fractions. This is called the fractional powers. And in this fraction, there is a numerator, there is a denominator. In this law, quickly, it states that the numerator remains the power. So this is still a raised to the power m. The numerator remains the power, but the denominator becomes the root. So this is n root. N becomes the root, m remains as the power. So in the laws of fractional powers, the numerator remains the power, the denominator becomes the root. Very important. A simple illustration of this law, if I have 27 raised to the power 2 over 3, for instance, this is a fractional power. 2 over 3 is a fraction, so we can apply the law of fractional powers. And when we do that, the numerator remains the power, 27 raised to the power 2, but the denominator becomes the root, which is the cube root. The cube root of 27 raised to the power 2. This is now a simple mathematics. There are 2 ways you can do this. Either you first of all look for the cube root of 27, and then your result you square it, or you find the square of 27, and the result you find the cube root. But the easier one is to start with the cube root of 27. So what is cube root of 27? Cube root means which number are you going to multiply itself in 3 places to have 27. That number is 3, because 3 times 3 times 3 will give you 27. 3 times 3 is 9. 9 times 3 is 27. So cube root of 27 is 3. I've simplified this and this to be 3, and then I still have my square. What is 3 square? 3 times 3, 9. So this is the application of the fractional powers. So I've run through the 6 laws of indices. Just go through it, peruse through it, listen to the video, play it. You can always pause it to understand the laws. In my subsequent videos, we will apply these laws in solving both simple and complex questions. Thank you. Kindly subscribe to my channel and share to your friends. Thank you.